Video version presents. Welcome, curious minds. Today we embark on a captivating journey to Mars, the red planet. We'll explore its myths, its science, and what the future holds for it. Get ready to uncover the secrets of this enigmatic world. Let's begin. Throughout human history, the cosmos has been a source of endless wonder. Among the celestial wonders, one celestial body has captivated our imagination like no other: Mars. The red planet, as it is aptly named, has fascinated astronomers and storytellers for millennia. Its fiery hue, visible to the naked eye, has inspired countless myths and legends. From ancient civilizations to modern science fiction, Mars holds a unique place in our collective consciousness. In this exploration of Mars, we embark on a captivating journey through time and knowledge. Let's delve into the intricate tapestry of mythology and religion, uncovering the diverse ways in which different cultures perceived and worshipped this celestial neighbor.
From ancient deities to celestial omens, Mars has left an indelible mark on human history and belief systems.
Our journey then takes us into the realm of science, where we'll examine the latest discoveries about this enigmatic planet.
We'll explore its geological composition, unravel the secrets of its thin atmosphere, and delve into the tantalizing evidence suggesting that Mars may have once harbored life.
Long before the invention of the telescope, our ancestors gazed up at the night sky, seeking meaning among the stars. Mars, with its distinctive reddish hue, held a particular allure, inspiring both awe and fear.
Unlike the fixed stars, Mars appeared to wander across the celestial canvas, its movements seemingly erratic and unpredictable. To many ancient civilizations, the appearance of Mars in the sky was often seen as an omen of war, chaos, or unrest. Its fiery color was associated with blood and conflict, and its unpredictable movements were interpreted as signs of the god's wrath. Astrologers carefully tracked the movements of Mars, believing that its position in the sky could influence the fate of nations and individuals.
While Mars is often associated with war and destruction, its connection to agriculture and fertility in some cultures adds another layer of complexity to its mythology.
In ancient Egypt, for instance, Mars was linked to Horus, the god of the sky, war, and protection. However, Horus was also a god of kingship and order, responsible for maintaining balance and fertility on Earth. The Egyptians believed that the annual flooding of the Nile River, essential for their agriculture, coincided with the rising of Sirius, the brightest star in the sky. Interestingly, Sirius rises just before Mars in the Egyptian sky, leading to an association between the two celestial bodies. This association suggests that Mars, despite its warlike connotations, may have also been seen as a guardian of agriculture and a bringer of life-giving waters. As we transition from the realm of mythology to that of science, it's fascinating to see how the ancient stories and beliefs associated with Mars continue to influence our modern understanding of this celestial neighbor. The very names we use for Mars and its moons, for example, are a testament to the enduring legacy of Roman folklore. Mars, named after the Roman god of war, still evokes images of conflict and conquest, even as we explore its surface with robotic emissaries in the name of peace and scientific discovery. The two Martian moons, Phobos and Deimos, named after the sons of Ares in Greek mythology, further reinforce this connection to war and violence.
For centuries, our understanding of Mars was shrouded in myth and speculation. However, with the advent of modern astronomy and space exploration, we have begun to peel back the layers of mystery, replacing ancient lore with scientific observation.
Today, our view of Mars is shaped by data beamed back from orbiting spacecraft and robotic rovers traversing its dusty plains. We now know that Mars is a terrestrial planet with a composition similar to that of our own Earth. Its surface bears witness to a dynamic geological past, marked by towering volcanoes, vast canyons, and polar ice caps that expand and contract with the seasons. Observations have revealed that the iconic red hue of Mars comes from iron oxide, essentially rust, which is prevalent in its soil and rocks.
The search for life beyond Earth is one of the most compelling endeavors of modern science, and Mars stands out as a prime candidate within our solar system.
Evidence suggesting that Mars may have once been warmer, wetter, and potentially habitable has intensified the search for signs of past or even present life. While no definitive proof of life on Mars has been found, several intriguing clues have emerged. One of the most significant discoveries is the presence of organic molecules, the building blocks of life as we know it. These molecules were detected in Martian soil samples analyzed by the Curiosity rover, indicating that the necessary ingredients for life were present on ancient Mars. While the presence of organic molecules does not necessarily confirm the existence of past life, it strengthens the possibility that life may have arisen on Mars in its distant past. Every rock, every crater, every layer of sediment on Mars tells a story. The story of a planet that has undergone dramatic transformations over billions of years. By studying the geology and geomorphology of Mars, scientists are piecing together a timeline of its evolution, from its fiery formation to its current state as a cold and arid world.
One of the most striking features of Mars is its dichotomy, the stark contrast between its northern and southern hemispheres. The northern lowlands are smoother and younger, while the southern highlands are heavily cratered and ancient. This dichotomy suggests a catastrophic event in Mars's early history, perhaps a massive impact that reshaped its surface.
The dawn of the space age unleashed a global fascination with space exploration, and Mars, with its alluring mystique, quickly emerged as a prime target. The dream of reaching the red planet captivated scientists and engineers, triggering a wave of ambitious missions designed to unlock its secrets.
The Soviet Union took the lead in the early days of Martian exploration, launching a series of probes in the 1960s. Though plagued by technical difficulties, these early missions demonstrated the immense challenges of interplanetary travel and paved the way for future endeavors. The vast distances, the unforgiving space environment, and the complexities of planetary landings posed formidable obstacles. The Mariner program laid the groundwork for even more ambitious missions, designed not just to observe Mars from afar, but to land on its surface. In 1971, the Soviet Union marked a historic milestone when its Mars 3 probe successfully landed on Mars, becoming the first spacecraft to achieve a soft landing on another planet. Though contact was lost shortly after touchdown, the mission represented a significant achievement in space exploration.
The United States achieved its own landing success in 1976 with the Viking program. Two identical spacecraft, Viking 1 and Viking 2, each consisting of an orbiter and a lander, were sent to explore the red planet. The Viking landers touched down on the Martian surface, marking the first successful long-term missions on Mars. The late 20th and early 21st centuries witnessed a paradigm shift in Mars exploration with the advent of rovers. These mobile laboratories, equipped with sophisticated instruments, revolutionized our ability to explore the Martian surface, providing unprecedented detail and expanding the scope of scientific inquiry.
The first rover to successfully operate on Mars was Sojourner, a small six-wheeled rover that landed on Mars in 1997 as part of NASA's Pathfinder mission. Sojourner captivated the world with its plucky exploration of the Martian terrain, demonstrating the feasibility of rovers for planetary exploration.
Each mission to Mars, from the early flybys to the sophisticated rovers that roam its surface today, has added a new chapter to our understanding of the red planet. We have moved beyond the realm of myth and speculation, replacing ancient lore with scientific observation and data-driven knowledge.
The discoveries made over the course of these missions have fundamentally changed our perception of Mars. We now know that Mars is not a static and unchanging world, but a dynamic planet with a rich and complex history. Evidence suggests that Mars may have once been a warmer, wetter, and potentially habitable planet, raising tantalizing questions about the possibility of past life.
The dream of colonizing Mars, once relegated to the realm of science fiction, is gradually transitioning into a tangible goal. While formidable challenges remain, the allure of establishing a permanent human presence on another world continues to drive technological innovation and fuel our collective imagination. But what drives this ambitious endeavor? The drive to colonize Mars stems from a complex interplay of scientific curiosity, a pioneering spirit, and a desire to ensure the long-term survival of humanity. Mars, with its potential to harbor resources and the possibility of terraforming, offers a potential plan B for humanity should Earth face catastrophic events, whether natural or human-made.
Transforming the inhospitable Martian environment into a habitable abode for humans is a formidable engineering challenge, requiring innovative solutions to overcome numerous obstacles. From the thin atmosphere and extreme temperatures to the lack of liquid water and harmful radiation, surviving and thriving on Mars demands ingenuity and adaptability.
One of the primary challenges is creating a breathable atmosphere. Mars's thin atmosphere, composed primarily of carbon dioxide, is unsuitable for humans. Proposed solutions include terraforming, a long-term process of intentionally altering the planet's atmosphere to resemble Earth's, and creating enclosed habitats with life support systems that provide oxygen, regulate temperature, and filter out harmful radiation.
As we contemplate the prospect of colonizing Mars, it is essential to consider the ethical and environmental implications. Terraforming another planet to suit our needs raises profound questions about our responsibility as stewards of the solar system and the potential impact on any indigenous life that might exist. One ethical dilemma revolves around planetary protection. How can we ensure that human exploration and colonization do not inadvertently contaminate Mars with terrestrial life, potentially jeopardizing scientific research into the origins of life on Mars, or worse yet, harming any potential Martian life forms? Establishing strict protocols for sterilizing equipment and carefully selecting landing sites are crucial steps in mitigating this risk.
From ancient myths to the latest scientific discoveries, Mars has captivated our collective imagination for millennia.
While the challenges of exploring and potentially colonizing Mars are immense, so too are the potential rewards.
Whether Mars harbors life, or whether it may one day host human colonies, the Red Planet beckons us to explore, to dream, and to expand our understanding of the universe and our place within it. If you enjoyed this video, don't forget to like and subscribe for more captivating content.